A triangle has vertices at -1 and 0, 5 and 0, and 2 and 6. We need to show that this is an isosceles triangle. Now, to make it easier, let's get an axis diagram to plot the points. -1 and 0 will be there, 5 and 0 will be there, and then 2 and 6 will be about there, if that is 6 on the y-axis. And then we can connect those points to see the shape of the triangle. Now, it looks like those two sides might be the equal sides to form an isosceles triangle. So we will first of all work out the lengths or the distances between the points. So let's call this triangle A, B, C, and then we've got A is 2 and 6, B is -1 and 0, and C is the 5 and 0. And then we first of all going to work out the distance of AB using the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. And then we can say, for instance, if that is x1 and x2, and this x1 and y1, sorry, x2 and y2, we'll get -1 minus 2 for the x's, so it's -1 minus 2 squared plus, and then for the y's we'll get 0 minus 6 squared. That will give me -1 minus 2 is 3 squared, is minus 3 squared is 9, plus -6 squared is 36, so it will give me a length or a distance for the side AB of square root 45. This is an irrational number, so we'll leave it as square root 5 for the time being. So it's square root 5 there. And then we do the same for AC. The length or the distance between A and C. Same formula. x2 minus x1 squared plus y2 minus y1 squared. And then we can say, again, let's call this x2 and y2. So we'll get 5 minus 2 for the x's squared plus 0 minus 6 as well. And then simplify this whole expression. 5 minus 2 is 3 squared is 9 plus -6 squared is 36. And again, we'll get the square root of 45 as the length of that side. And then to get the distance between B and C, we can simply count along the axis, the x-axis. It's 1, 2, 3, 4, 5, 6 units. So obviously that side BC is not the same length as either AB or AC. But what is important is that AB and AC are equal in length, so it makes this triangle an isosceles triangle.